this video we will discuss about the concentration terms. These are the terms which is defined for the homogeneous solution. Homogeneous solution. Some of the concentration terms will depend on the temperature and others are not. So the concentration term which depends on the temperature we can say that the temperature dependent concentration terms are those which involves the volume. So the concentration term which involves the volume, that will depends on the temperature, because the volume depends on the temperature. So we can say that percentage W by V, percentage V by V, molarity capital M, volume strength of H2O2, volume strength of H2O2, normality. All these are the concentration term which involves volume, so these will depends on the temperature. So the other category, we can say that the other concentration term which don't depends on the temperature, we can say that temperature independent concentration terms. So temperature independent concentration terms are those which only involves mass, not the volume. Only involves mass. We can say that we express the concentration by these concentration terms in terms of mass. So we can say that percentage by mass, ppm parts per million, molality small m. All these are the concentration terms which only involves mass, so these are temperature independent term. We can have the one more category of the concentration term which is called typical concentration terms. Typical concentration terms. So what are typical concentration terms? Because these concentration terms are especially used for particular compounds. For example, for H2O2 we will use volume strength. Volume strength. This concentration term volume strength is discussed separately in hydrogen chapter, and the concentration, second typical concentration term is percentage labeling for oleum. Percentage labeling for oleum. So let's understand the meaning of each concentration term and how we can decode all these concentration terms. So let's start with the percentage by mass. Percentage by mass, which is written as percentage W by W, or simply we can write this weight of solute. Weight of solute upon weight of solution into 100. Now how we can decode this concentration term properly? Suppose if a bottle is labeled by 10% W by W NaOH and the density of this solution is 1.2 gram per ml, then how we can decode this concentration term? It means that 10 gram of NaOH is present in 100 gram of solution. So we can say that 10 gram of NaOH or 1 by 4 moles of NaOH is present in 100 gram of solution. So it is very obvious that the mass of solution is 100 gram and the mass of solute is 10 gram, and the moles of solute is 1/4 moles gram. So we can easily find the mass of solvent. Definitely mass of solvent is useful because it is required to calculate the molality of solution. So mass of solvent will be 100 minus 10, that will be equal to 90 gram. One thing more, we can also calculate the volume of solution. We know that volume of solution is required to calculate the molarity of solution. So volume of solution will be equal to mass of solution, which is 100 gram, and the density of solution, which is 1.2 gram per ml. So the volume of solution will be equal to 100 upon 1.2 ml. So this is the decoding by which we can understand the meaning of percentage W by W. We can take one more concentration term, which is percentage W by V. Percentage W by V, we can say that mass by volume. It is to be noted that sometime in the examination, while dealing with the mole concept or problems related to the mole concept, simply percentage is given, not mentioning the percentage W by W or percentage W by V. So it is advisable to consider that percentage by mass. So the percentage W by V, how we can understand this term, that is weight of solute upon volume of solution into 100. So how we can decode these concentration terms? Again, if a bottle is labeled by 10% W by V in NaOH and the density of this solution is 1.2 gram per ml. So how we can decode this? Definitely we will say 10 gram of NaOH or 1/4 mole of NaOH will be present in 100 ml of solution, right? So this time we are saying that the 10 gram of solute, which is NaOH here, will be present in 100 ml of solution. The percentage W by W, it was 100 gram of solution, and in percentage W by V, it is 100 ml of solution. So what is the mass of solvent in this case? So definitely mass of solvent, that will be equal to mass of solution. So mass of solution will be volume into density minus weight of solute, that will be equal to 10. Definitely this will be the mass of solvent. So in this video we have discussed about the two concentration term, which is percentage by mass and percentage W by V. In the next video we will discuss the other concentration terms and we will solve more problem on this. Thank you very much.